part as we go on. So the next thing we're going to do, we can kind of forget about the whole idea of the balanced equation, and let's sort of focus on some things. So I'm going to do this one right here in orange, all right? And I'm going to use my periodic table, and in my periodic table, I'm going to look and I'm going to say, okay, let's do this up here. So I got C, and I got 2 C's, and I got H, and I have 4. Where am I getting these numbers from again?
Periodic table.
Well, not quite yet. I'm just using the subscripts right here, 2 and 4. Not quite yet, but you're on the right track. Now I'm going to make it simple on us and simple on you and simple on me by just taking the whole number from the periodic table. If I look at the number, it says 12.01. I'm going to just say 12. I'm going to round it to the whole number. All right, so 2 plus 2 times 12 is 24, right? Whole numbers, I like whole numbers. What would be my whole number from hydrogen?
4.
It would be, well, from the periodic table, would be 1, and then you're right, it eventually would be 4. Good, so boom, 28.
Is that our mass?
That is our mass. So I'm going to put 28 right here. All right.
So amazingly amazing.
Oh boy. Okay, so next I'm going to do carbon dioxide in green. So I'm going to list my atoms C and O. And you'll notice when I do this, it's very repetitive, which is good and bad, because if you know how to do it, then it's just repeating the same thing over and over, and you get all kinds of easy points on the assessment. But again, how many carbons are there? There's 1 carbon. How many oxygens are there? There are 2. How did I know that? I look, and even though there's not a 1 right here, I know there's really a 1. There's only 1 carbon, and there's a 2 right here, and that means that we have the 2. Okay, so then I say, all right, I'm going to go to the periodic table. The periodic table says 12.01. So I'm going to go ahead and round that to 12. Actually, it says 12.011, but I digress. Next up, what does oxygen say on the periodic table? If you look at oxygen, oxygen says 15.999.
4.
Let's go ahead and make that
16.
16. That keeps things simple for us. All right. So then I say, all right, cool. This is 12. Do a little multiplying. 2 times 16 is 32, which is great. If I got 32, that's fantastic. I do a little addition here, and you can add that up. And when I add that up, that gives me an answer of 44. Questions on that so far? The next one's fairly easy because it's only got one element. I have oxygen. There are 2 of them, and the rounding I use, 15.99 becomes 16, and that becomes 32. 32. So I put 32 right in here. All right. The next thing I'm going to do water, which is a good one. I have 2 waters. Oops. And I have 1 oxygen. On the periodic table, I'm going to say 1.008 becomes 1. And oxygen, 15.99 becomes 16. Again, rounding to the whole number. This is 2. This is 16. And I add that up, and I get the number of 18. So all these are very important numbers. I want to make sure I'm focusing on these numbers and paying attention to these numbers right here. All right. Any questions so far? Making sense? If I look up before, I use my balanced equation. I'll look at your paper where it says moles right here. Where it says moles right here, this refers to your balanced equation. So the coefficients are what matter. So I can go up there, and I know from my balanced equation I have 1, 3, 2, and 2. The nice thing about this problem is that even though you're given 8 blanks to figure out, right here. So if you look, I got 8 blanks, 4 on this side and 4 on this side to figure out. I really already know 4 of them from the balanced equation, which means knowing how to balance equations are really important. And then we're always going to give you a mass, 264 right here, okay? We're going to give you that mass right there. So the next thing we need to do is we need to focus on how can we figure out this blank, and this blank. And it's sort of complicated, but I think we can do it, all right? So let's give it a little chance here, okay? A nice thing is we're basically going to use information that we've already figured out to figure out what we want to figure out. So the very first thing I'm going to do is I'm going to start with, I'm going to try to solve for this one right here, the mass of C2H4. Well, that is going to start with my buddy, what I was given here, 264 grams of carbon dioxide. So this is how it's going to work. I'm going to take 264 grams of CO2, all right? And I'm going to multiply this by a few things. The first thing I'm going to multiply is I'm going to say, well, in order to be able to exchange or go from CO2, if I wanted to go from CO2 to C2H4, the only way I can do this is by using the idea of a mole, okay? So being in grams does me no good. So I want to convert this to moles. So I say, oh, all right. I know previously on ICP, if I go up to CO2, so go up to the molar mass. Look on your paper right now, and you'll find molar mass. What is the molar mass for carbon dioxide? 44. So I put 44 grams of CO2, and that always equals 1 mole of CO2. All right? Okay, if we do that, that's great. Then what we're going to do now is we're going to say, okay, if we go from, so now we got this in moles. We've actually accomplished our goal of getting this to moles. But now I need to know for every mole of CO2, how many moles of C2H4 do I have? Well, I know that because I said it right here. Look, for every 2 moles of CO2, I have 1 mole of this. So I'm just going to go ahead and I'm going to write this like this. I'm going to say, okay, cool, let me do this. So I'm going to say for every blank moles of CO2, I have blank moles of C2H4. I know my writing's not perfect, but hey. So then I say, oh, wait a minute, I got this. If I say 2, where am I getting this 2 from again? Moles of CO2 right here. So the 2 will then go right here. And then I'll say, all right, how many moles of C2H4 do I have? 1. Cool. So I'll put that right there. Hey, now I'm in business because now all I have to do, now that I got it to moles, the question is asking me, what's the mass? And I'll say, wait a minute, if you want to know mass, I can take that from moles to mass really easy. I can do that by going up to the above equation and say, okay, for every 1 mole of C2H4 I have, again, not really great writing, sorry about that, I have so many grams of C2H4. How many grams is it per mole? Look up on the top where it says molar mass in bold and in caps, and we know that is 28, okay? 28. I've done it. All I need to do now is remember how to use my calculator. So what I'm going to do on my calculator is I'm going to multiply all the numerators. So on my calculator, I'm going to type 264, and I'm going to multiply 264. Do I need to multiply by 1?
No.
That's kind of silly. I'm going to multiply it by 28, and I'm going to hit enter. That gives me 7,392, which is fantastic. Now I'm going to divide by all of my denominators, right? So I divide by 44 first, and then I hit enter. And then I divide by 2, and I hit enter. And my answer, sounds like your answer too, would then be, I go up here, And I put 84. Yippee. It is 84 grams, right? Good job. Now, if we look here, we're going to do it some more. Let's go ahead and do oxygen next. Now, if you notice, I left 264 there because really, I'm starting the same way. I'm just going to end a little different here, okay? So if I look at this and I say, again, it's all about the mole to mole. So if I say, okay, well, then I'm going to say for moles of CO2 to moles of, what are we doing again? Oxygen. I say, okay, cool. I know for every, what am I looking at here? Oh yeah, CO2. For every 2 moles of oxygen, I have 3 moles of, for every 2 moles of carbon dioxide, I have 3 moles of oxygen. Cool, I can do that. Let's do it. So I put my 2 on the bottom because that's what I got right here. And I put my 3 on the top because that's what I got right here. Now I've solved this. I have it in moles, but I still need to do one more thing, which is fantastic. I can do that no problem. I say, well, if I want to turn moles of oxygen into grams of oxygen, I've already done the work. I go up top and I look and I say, bingo, I got 32 grams of oxygen for every 1 mole. Now you'll notice something great, and what that is, and I didn't show this on the example before, but that is every time I go, I cancel something out. So I cancel my moles of oxygen out. I cancel my moles of, and I'm going to leave this here. This gets canceled out right here, and this gets canceled out here. I'm not crossing it out because I kind of want to leave it for the next round. I don't know how to do this in my head, so I'm going to go ahead and I'm going to grab my calculator. I'm going to hit clear, and I'm going to start again with my 264 multiplied by 3, because it's in the numerator. Enter. It's important you hit enter. 792 is what I get. And then I'm going to multiply it by 32. Great. Boom. Now I got denominators here. I'm going to then hit divide by 44. Enter. And am I done?
No.
Nope. I still need to divide by 2. Divide by 2 equals 288 is my answer. So I'll go up here and I'll put 288. Is that what you got? Last but not least, I'm going to do it for water, okay? And I'm kind of tight on time, which is fine, but maybe you can do it. Who knows? Again, I start my same way and I say, all right, water, I got you. I'm going to go moles of CO2, moles of H2O. That's great. That's fine. Where do I get these numbers from again? Oh, yeah. I go right here and I say, hey, you're 2. So I put 2 right there. And then I say, water, you have 2 also. Well, what's the good news about that? They kind of cancel each other out, right? So then I say, cool, moles of water, good for me. I did it. Now I need to convert this to grams of water, and I say, wait a minute, how many grams of water equals a mole of water? I've done it already. I just go up here, 18 equals 1 mole. And this is so great. Again, my moles of water cancel out, my moles of carbon dioxide cancel out, and my grams of carbon dioxide cancel out, and I'm left with grams of water, which was the whole point in the first place. I do some multiplying and some dividing. So I go 264 times 18. I don't really need to do 2 because 2's down here. So cancel you, get out of here. Divided by 44 equals 108. All right. Now, here's the thing. If you notice, the total masses of these 84 plus 288 is 372, right? That belongs down below in total masses of reactants. We'll remember that. That's probably pretty important. 372. How am I going to find the total masses of the products? Add this right here. 264 plus 108 equals, wouldn't you know it, 372. Awesome sauce. I go right here, 372, 372. I did it. I'm amazing. Some important information there. You have to balance things right to make it work, okay? Very important.